Well, I always liked science as a kid, but I think what really brought me into it was a lot of science fiction shows, specifically Star Trek a lot, but I used to watch all types of science shows and documentaries. It's just always been there.
Now tell us, what is a radio observatory?
A radio observatory is a lot of radio telescopes all electronically linked together, and we like to look at the universe at different frequencies than our normal eyes do. So a radio observatory looks at the universe and the radio frequencies.
Now, you use the radio telescope to study galaxies, and you're actually at times looking back in time. Tell us about that.
Yeah, so if you look far enough away in the universe, because the speed of light takes a certain amount of time to reach us, you're actually looking back in time as the galaxies or the object you're studying was at the time that it emitted that light and those photons. So if you look far enough back, you're actually looking back in time.
Now, is it true that if you look at something far enough away, the light that you're seeing left those stars when there may have been dinosaurs on Earth? Can you see that far back?
Absolutely. So that would be about 65 million years, which we can absolutely see that far back. In fact, it's considered backyard astronomy. That's what I do. I look at the nearby universe. So typically the data that I get was emitted back when there were dinosaurs on Earth. I specifically look at galaxies and I use VLA data, but the VLA does a lot more than that. But I specifically look at nearby galaxies. The galaxy is a collection of stars, gas and dust. It has lots of components. They all interact with each other. And they're going to have different properties. So we can study those properties in different types of galaxies, see how they compare across types of galaxies.
So what else is being done at the VLA?
Well, the VLA does do some solar system stuff. We look at the sun and planets a little bit, but for the most part we look a lot at galaxies, near and far, and we look at regions within galaxies like star-forming regions, supernova remnants, all types of things.
And as a matter of fact, we're quite a ways away from the dishes right now, and that's for a very specific reason, something that just came up yesterday, right?
Yeah, so just yesterday we had a fast radio burst emission, which we don't really understand what they are, but they are what we call targets of opportunity, so we want to study them as soon as they pop up, for as long as we can. And the VLA is really good for this because those radio bursts come to us with a sort of delay. So when we hear about the observation, we can try to point and look and try to observe this thing.
Right now we're using a wired microphone. Normally we use wireless microphone packs, and we had to turn all of our cell phones off before we came in. Why is that? Well,
we care a lot about interferences, specifically radio frequency interferences, because they basically mess up our data a lot. So we try to limit as much as we can any type of Wi-Fi technology, cell phones, even cameras, everything that we can.
Now, we drove over some train tracks as we were driving in. These aren't stationary dishes, are they?
No, they're not. So the VLA actually changes its shape 4 times a year, about. It's always in the shape of a Y configuration, but the dishes will be closer together or near apart depending on when you come to visit. The reason for this is that you can access different types of science with the different configurations.
So what kinds of science?
Well, specifically the difference between the different configurations is going to be in the level of detail that you can see. So when the array is really compact and you have all the telescopes close together, you can basically see not so much detail, but you'll have a greater field of view on the sky, and you'll be able to see emission that's a bit less bright than other stuff. Each arm can extend up to 13 miles in each direction. So when we're basically in the larger configuration, up to 13 miles, that's when you get access to the finer resolution and smaller pixels on your image. So you get a lot finer images, but also a smaller field of view. And usually you only see the more brighter stuff.
You're using radio frequencies to create an image. How does that work?
So what the telescopes are actually doing is they're collecting photons or waves, just like optical telescopes do, or even our eyes. Our eyes actually collect optical photons. These telescopes are basically bigger eyes, and they work at a different frequency, but overall it's kind of the same mechanism. So we're collecting radio photons or radio waves, and because the radio waves are physically bigger than optical waves, which is why we want bigger telescopes. But then we get this electronic signal, which we can all combine. We can combine together the signal from all the dishes together, and then we can actually get images or maps of the region of the sky the telescopes were pointing at.
Looking out at the dishes, which we can see way off in the distance, are they equally spaced, or does that distance vary?
So the distance actually varies, and also when you change the configuration, all the distances are going to vary accordingly.
Okay.
There's actually 28 telescopes in the VLA. We only use 27 at a time at most, but that's because there's always going to be one that's going to be out for maintenance. So you actually physically remove receivers on the telescope to do some type of maintenance on it, or at least you electronically take it out of the array so it's not contributing anymore. But there is always a backup.
We are quite a ways away from these dishes, but they look enormous. How big are they actually?
So the diameter of each dish is 25 meters, and they're actually about 25 meters above the ground as well, and they weigh 200 tons each.
200 tons?
Yes.
And to move them, there's like a vehicle on the train tracks that comes over, goes underneath it, and lifts them up. Is that right?
Yes, there's a crawler that goes to the telescope, lifts it up, sets it with hydraulic jacks onto the crawler, and it crawls along at 5 miles per hour to the next pad where it's going to set the telescope down during the configuration change.
And you can see the different pads in the distance, and I assume that those are the different locations that the different dishes could go.
Yeah.
So driving to the telescope today, we noticed that this really looks like a big bowl, this landscape. Tell me about why this area and why New Mexico for the very, very large array.
We are far south, so we do see 82% of the sky from here, which is great. We're also at a high altitude, and we are in a really dry climate, being in the New Mexican desert. And also, we're surrounded by those mountains over here, which really shield out all the interference and the radiation from human activity and cities away from us.
We've moved a lot closer, and you can really make out the different parts of the dish. What all am I seeing here?
So this is one of the 27 telescopes that makes up the Very Large Array. There's 27 of them, and they're all electronically linked together to function as one. But there are 27 individual parts, but they're also all the same. So for this one here, as for all the other telescopes, what you see, the main structure is the gigantic dish, the bowl-shaped dish, and that's simply the primary reflector. And it's painted with a coating that's reflective, or that's acting like a mirror to the radio waves. So if you're a radio photon and you're incoming and you see this dish, you're going to bounce off of it. It's going to act as a mirror to you. So it's going to bounce off, it's going to be focused at the secondary reflector, which we see on top, and then from there they get bounced down to the center of the dish where we actually have the receivers, and that's where the science can actually happen.
Why is it important to have more than one telescope in an array?
Well, the more telescopes you have, the better your final image will be. For one thing, you simply have more collecting areas, so you're collecting more photons or more radio waves, you're going to get a better image. But also, specifically in a radio array, each pair of telescopes contributes to some of the information that you're going to have about the region of the sky that you're observing.
So if somebody wants to learn more about the VLA, how can they go about finding out more information?
Well, the VLA website has all types of educational resources. We have also all the scientific press releases that you can read up on. And we have a virtual tour of the observatory. And of course, if you come in person, you can come and get a tour anytime as well.
Sounds great. And it is gorgeous here. Thank you so much for talking with us.
Thank you.